Hello there, and welcome to Sleepy Science Vault. Somewhere in your mind, right now, there is a memory you would swear is perfect. Maybe it's the sound of rain on a window from your childhood, or the exact words someone said to you on a day that mattered. You can see it. You can feel it. It seems untouched by time, sitting there in storage, waiting to be replayed exactly as it happened. But here's where our story begins tonight. That memory has likely already changed. Not because you're forgetful. Not because your mind is broken or unreliable in some obvious way. It's because of something far stranger and far more universal than most people realize. The human memory was never built to work like a video recorder. It was never meant to capture an experience once and preserve it, frame by frame, forever. Tonight, we're going to explore 100 facts about a subject that touches every single person who has ever remembered anything, which is to say, every person who has ever lived. We're going to explore the science of false memories. How they form. Why they feel so real. And what they reveal about the quiet, constant editing process happening inside your mind every day, whether you notice it or not. This is not a story about lying, or imagination running wild, or anything shameful about the way your brain works. It's simply how memory operates, for everyone. Scientists, doctors, judges, grandparents, children. No one is exempt from this. And understanding it doesn't make your memories less meaningful. If anything, it makes them more fascinating. So settle in. Let your mind soften, the way it does before sleep, when thoughts start to drift and wander on their own. There's no need to hold on to every detail tonight. Let the facts move through you gently, like a tide, and take with you only what your mind naturally chooses to keep. Let's begin. For a very long time, people assumed memory worked something like a camera. Pointed at an event, press record, and the moment gets filed away somewhere in the brain, intact, unchanged, ready to be pulled up again whenever needed. It's a comforting idea. It suggests that our past is fixed, solid, something we can always return to and trust completely. But that is not how memory actually works. Memory works more like reconstruction than playback. Each time you recall something, your brain isn't retrieving a finished file. It's rebuilding the memory, piece by piece, in that very moment. And because it's being rebuilt rather than replayed, small details can shift. A color might change. A voice might soften or sharpen. The order of events might quietly rearrange itself, without your awareness. This means that every time you remember something, you are, in a very real sense, remembering the last time you remembered it, more than the original event itself. Each retelling becomes a new version, layered gently over the one before it. Most of the time, these changes are so small you'd never notice. But they accumulate. Slowly. Silently. Across years. This single idea, memory as reconstruction, not replay, changes almost everything we thought we understood about the past living inside us. Some researchers have taken this even further. They describe memory not simply as reconstruction, but as selective retrieval. This means the brain doesn't just passively rebuild a memory, It actively edits it. It chooses. It emphasizes certain details and quietly drops others. It fills gaps with what feels plausible, even if what feels plausible isn't what actually happened. Think about that for a moment. Your brain isn't just an imperfect recorder. It is an active editor, working behind the scenes of your awareness, shaping the past into a version that makes sense to you now, in this present moment. Not out of dishonesty. Out of efficiency. The brain doesn't have the storage or the need to preserve every sensory detail of every experience. So it summarizes. It generalizes. It fills in blanks with reasonable guesses. And this editing process happens so smoothly, so invisibly, that you experience the final result as simply remembering. There is no warning label. No little flag that pops up to say, this part is accurate, this part has been softened, this part was filled in by inference. It all feels seamless. Whole. True. Which leads us to something quietly unsettling and quietly fascinating, all at once. People can feel very confident about a memory even when it is inaccurate. This is one of the most important facts in the entire science of memory, so let it settle for a moment. Confidence and accuracy are not the same thing. They feel like they should be connected. Surely, if I remember something clearly, vividly, with strong emotion attached to it, that must mean it really happened that way. But research again and again shows this isn't reliable. Some of the most emotionally vivid memories a person holds can be, in certain details, simply wrong. This isn't a flaw limited to people with poor memory, either. In fact, some studies suggest the opposite pattern can occur. People with very strong general recall can sometimes be just as susceptible, because their minds are so good at constructing detailed, convincing scenes, even from fragments. So when someone says, I know this happened, I remember it perfectly, that certainty, however sincere, however heartfelt, is not proof. It's simply a feeling. A powerful one. But a feeling, nonetheless, generated by the same reconstructive machinery we've been describing. This brings us gently into the heart of tonight's subject. False memories are not simple forgetting. Forgetting is when something fades, when a detail slips away and leaves a gap, a blank space you're aware of. False memory is different, and in some ways, stranger. It isn't a blank space. It's a filled space, filled with something that feels complete, vivid, and real, despite the fact that it never happened, or didn't happen the way it's being remembered. Imagine recalling a birthday party from childhood. The cake. The song. A particular gift you received. You can picture the room, the way the light came through the window, maybe even the taste of the frosting. And yet, some detail, or perhaps the entire event, may be a construction, built later from photographs, family stories, or simple imagination, rather than lived experience. It doesn't feel like an absence. It feels like a memory. That's what makes false memories so difficult to identify, both for the person experiencing them and for the people around them. And this leads to a fact that carries real weight, well beyond casual curiosity. False memories can be factually incorrect but strongly believed, and this combination is precisely what makes them so hard to detect. If a memory felt uncertain, fuzzy, or doubtful, we would naturally treat it with caution. We'd say, "I think this happened, but I'm not sure." But false memories often arrive with none of that hesitation. They come dressed in full confidence, complete with sensory detail and emotional resonance. This has enormous implications in courtrooms, in therapy, in family relationships, in personal identity itself. A person isn't lying when they report a false memory with total conviction. From their perspective, they are simply remembering. The subjective experience of a false memory and a true memory can feel, internally, identical. Let that settle for a while as we move a little deeper into the shape of these memories. Not all false memories are the same. Some, though relatively rare, are close to complete inventions, entire events that never occurred at all, existing seemingly from nowhere. But far more commonly, false memories are something more delicate, more layered. They mix real details with incorrect ones. A memory might be built around something that truly happened, but with pieces added, swapped, or subtly distorted along the way. This is an important distinction to sit with. Most false memories aren't pure fantasy. They're closer to a quilt, stitched together from different sources, some threads pulled from genuine experience, others woven in later, from suggestion, imagination, or simply the passage of time. Which brings us to one of the clearest explanations researchers have offered for how these memories actually form. Some false memories are built from true memory fragments, with false details added on top, rather than being invented completely out of nothing. Picture a real childhood memory, a trip to a lake, perhaps. The core of it is genuine. You were there. But somewhere along the way, a detail gets added. Someone mentions a dog was there, and eventually, you can picture that dog. You did not invent the entire day. Your mind simply absorbed a new piece, and quietly folded it into the true memory as though it always belonged there. This is part of why false memories can feel so convincing. They are not built from nothing. They're built from something real, with just enough alteration to shift the story. And imagination itself plays a far larger role in memory than most people ever suspect. False memories can be built from true memories plus imagination, rather than appearing from nowhere. When you imagine a scenario vividly enough, picture it, describe it, replay it in your mind repeatedly, that mental rehearsal can begin to resemble an actual memory trace. The brain, in certain ways, doesn't always clearly separate something vividly imagined from something genuinely experienced. Both processes activate strikingly similar regions. This means that simply picturing an event in rich detail, again and again, even one you know intellectually never happened, can gradually make it feel like it did. Not because you're being careless. Because imagination and memory share more neural territory than most people ever realize. This idea deepens even further when we consider how many different ingredients can combine at once. False memories can form from a mix of imagined elements and factual memories, rather than from pure invention alone. It's rarely just one distortion or one added detail. Often, it's a blend, a true setting, an imagined conversation, a borrowed detail from someone else's account, all merging together into a single, coherent memory that feels like one continuous experience, rather than the patchwork it actually is. Your mind is remarkably good at smoothing these seams. It doesn't present a memory to you as fragmented pieces, some true, some imagined, some borrowed. It presents a single, polished narrative. Complete. Whole. Convincing. And this brings us to perhaps the clearest way to summarize everything we've explored so far tonight. False memory is often described as a new memory, formed by combining an older memory with false information, rather than something appearing fully formed from scratch. It's not creation from nothing. It's recombination, an old memory, still holding traces of something real, merged quietly with new information that was never part of the original event. The result is neither fully true nor fully false. It exists somewhere in between, wearing the full confidence of certainty, while carrying, hidden inside it, threads that don't belong. This is the strange, quiet truth sitting at the center of human memory. It is not a vault. It is not a recording. It is a living, breathing process, rebuilding itself, again and again, every time you reach into the past. And this is only the beginning of what we'll explore together tonight. In the next set of facts, we'll go even deeper into the moments researchers first began to understand just how easily these false memories can be shaped, and what that discovery meant for the way we think about truth, trust, and the fragile, fascinating architecture of the remembering mind. For now, let your thoughts rest here for a moment, on the quiet realization that even your most treasured memories may be, in small ways, gently reimagined each time you visit them, and that this doesn't make them any less yours. You don't need a laboratory, a set of instructions, a research assistant, a controlled experiment, for memory distortion to happen. It's already happening. Quietly. Constantly. In the ordinary moments of your everyday life. Memory distortion can happen even in everyday life, not just in lab experiments. This is worth sitting with for a moment, because it's easy to imagine false memories as something rare, something that only occurs under strange or extreme circumstances. But that's not the case. It happens when you retell a story at dinner and unconsciously smooth over an awkward pause that was actually there. It happens when you recall an argument and remember yourself as calmer than you were. It happens in the small, human moments of daily life, so gradually that you'd never notice the shift occurring in real time. This is not a malfunction. It's simply how a reconstructive memory system behaves, out in the world, every single day. And there's a particular ingredient that makes this drift even more pronounced: time. Time can make memories less reliable, especially when the original event is old or faded. This makes intuitive sense, and yet it's worth understanding why. As time passes, the original sensory details of an experience, the exact words spoken, the precise sequence of events, begin to fade. But the general feeling of the memory, its overall shape, tends to remain. And when specific details fade while the general impression stays intact, the mind often reaches for something to fill that space. It borrows. It infers. It reconstructs, using whatever feels most plausible. The result is a memory that feels just as strong as it did years ago, but the fine details inside it may have quietly shifted, replaced, or invented, somewhere along the way, without your awareness. You might assume that remembering something often, returning to it again and again, would protect it from this kind of drift. In some ways, it does. Repeated recall can strengthen a memory, but it can also reshape it over time. This is one of memory's more paradoxical qualities. Each time you recall an event, the neural pathway associated with that memory becomes more accessible, more stable in certain ways. This is why frequently told stories often feel so solid, so certain, in the mind of the person telling them. But here's the paradox. Each act of recall is also an act of reconstruction, as we explored earlier. So while repetition can strengthen the feeling of certainty, it doesn't necessarily preserve accuracy. In fact, sometimes the opposite happens. Each retelling offers another opportunity for small distortions to slip in, and then, through repetition, those distortions become woven more firmly into the fabric of the memory itself. The story becomes smoother with each telling, but smoother isn't always the same as truer. Now we come to one of the most well-documented and significant forces behind memory distortion, something that comes not from within the mind, but from outside it. Suggestion can shape memory, which means outside information can influence what you think happened. This is a profound idea, because it means memory isn't sealed off, protected from the world once an event has occurred. It remains open, porous, capable of absorbing new information, long after the original experience has ended. A simple question, phrased a certain way. A comment from a friend, describing an event slightly differently than you remember it. A photograph that shows something you don't quite recall, but which starts to feel familiar the more you look at it. All of these can quietly work their way into memory, blending with what was originally there, until the line between what you experienced and what you were told becomes difficult, sometimes impossible, to locate again. This isn't weakness. It's simply how an open, adaptive memory system interacts with an ongoing stream of new information. Your mind was never designed to lock a memory away in isolation. It was designed to keep updating, integrating, connecting new information to old, for practical reasons, to help you learn, adapt, and make sense of a changing world. To understand how this happens more precisely, researchers point to something called source monitoring failure. One source of memory error is source monitoring failure, where people confuse imagined or inferred events with real ones. Think of your mind as constantly receiving information from many different sources at once, things you directly experienced, things you imagined, things you inferred or guessed, things other people told you. Under normal circumstances, your brain does a remarkable job of tagging each piece of information with its correct origin. This came from experience. This came from imagination. This came from a conversation. But that tagging system isn't perfect. Sometimes, the label gets lost, or attached incorrectly. And when that happens, a piece of information that originated in imagination or inference can end up filed away under the category of real experience, not because you intended to deceive anyone, including yourself, but because the internal labeling process simply slipped. This single mechanism explains a remarkable amount of what we've discussed so far tonight. False memories can form when people misattribute a mental experience to the wrong source, such as confusing imagination with real experience. Imagine picturing a scenario vividly in your mind, perhaps imagining how a conversation might unfold before it happens, or picturing what a childhood home might have looked like, based on old photographs and family stories. That mental image is created internally. It exists only in your imagination. But if the internal tagging system misfires, even slightly, that same imagined scene can later be recalled without its correct label attached. And once that label is missing, the imagined scene doesn't feel like something you pictured, it feels like something you remember. The vividness remains. Only the source information has been lost along the way. This leads us to a phenomenon with a particularly fitting name. Imagination inflation can make imagined events feel more familiar, and therefore more believable, over time. There's something quietly poetic about this term, inflation, as though imagination, given enough time and repetition, gradually expands, gaining weight and presence, until it feels as substantial as something real. And in a way, that's exactly what happens. The more vividly and repeatedly you imagine something, even something you know, intellectually, never occurred, the more familiar that image becomes to your mind. And familiarity is one of the primary cues your brain uses to judge what's real. If something feels familiar, the mind tends to assume, this must be something I've encountered before. Imagination, given enough repetition, can create that same sense of familiarity, all on its own, without any real experience behind it. This is worth pausing on, because it reveals something quietly profound about the human mind. The simple act of picturing something clearly, again and again, can be enough to make it feel like a memory, even in the complete absence of any real event behind it. Memory distortion can happen through imagination inflation, where imagining an event makes it feel more familiar later. This isn't limited to dramatic or unusual circumstances. Something as ordinary as vividly picturing how you'll respond to an upcoming difficult conversation, imagining it multiple times, in detail, can afterward leave behind a strange, quiet impression that the conversation, or something close to it, already happened. The mind, in a sense, cannot always tell the difference between rehearsal and reality, once enough time has passed and the vividness of the imagined scene has settled comfortably alongside genuine memories. This connects closely to another well-studied form of memory distortion, one that involves a very particular, familiar feeling. False recognition is a common form of memory distortion, where someone thinks they saw something before when they did not. You may have experienced a small version of this yourself, walking into a room and feeling a faint, inexplicable sense that you've been there before, even though you know, logically, that you haven't. Or recognizing a face in a crowd, feeling certain you've met this person somewhere, only to realize later that you haven't. False recognition happens when the brain's sense of familiarity becomes triggered without a genuine memory to anchor it. Something about the current experience, a shape, a sound, a pattern, resembles something stored in memory closely enough to activate that warm, familiar feeling, even though the specific event being recognized never actually occurred. The feeling of recognition and the fact of genuine memory can, once again, become separated from each other, quietly, without your awareness. And this brings us to one final, fascinating piece for tonight's exploration, a process that reveals just how creatively, and sometimes unpredictably, the memory system can behave. Associative memory errors can occur when the brain links unrelated experiences together and later treats them as one event. Human memory doesn't store each experience in a separate, isolated compartment. It connects experiences to each other, constantly, through shared themes, similar emotions, related settings, or overlapping details. This associative quality is, in many ways, a strength. It's part of what allows creativity, pattern recognition, and quick, intuitive thinking to occur. But this same strength carries a quiet cost. When two separate experiences share enough similarities, the brain can sometimes merge them together, treating them as a single memory rather than two distinct ones. Details from one event can blend into another. A conversation from one evening might merge, in memory, with a similar conversation from an entirely different night. The mind isn't lying. It's simply doing what association-based systems naturally do, connecting related information together, sometimes a little too generously. So here we are, resting for a moment at the edge of something remarkable. Everyday life, ordinary time passing, simple repetition, gentle suggestion, the quiet slipping of source tags, the surprising power of imagination, the soft pull of false recognition, and the natural tendency of the mind to link related things together, all of these, working quietly beneath conscious awareness, shaping and reshaping the story of your past. None of this makes memory untrustworthy in some dramatic, alarming sense. It simply reveals memory for what it truly is, not a fixed archive, but a living, adaptive, deeply human process, still unfolding every time you reach into it. In the next set of facts, we'll move further into the science behind this, into the specific research and discoveries that first revealed just how far this reconstructive process can go, and what it can teach us about trust, testimony, and the quiet architecture of belief. For now, let this settle gently, the understanding that your mind isn't failing you when memories shift and blend. It's simply doing what it has always done, quietly, patiently, in the background of every waking moment, weaving the past into something it can carry forward, a little more smoothly, with each gentle retelling. There is a particular kind of memory error that doesn't come from imagination, or suggestion, or the slow drift of time. It comes from something far more basic to the way your mind processes experience in the very first moment it happens, the way meaning and detail quietly separate from each other. False memories can also come from gist-based errors, where the general meaning is remembered but the exact details are lost or altered. Consider how you experience a conversation. You don't retain every single word spoken, in perfect order, like a transcript. What you retain, most naturally, is the meaning of what was said, the gist. And this makes sense, practically speaking. Meaning is what helps you navigate the world. Exact wording, most of the time, isn't necessary to carry forward. But this efficient shortcut comes with a quiet cost. When your mind later tries to reconstruct the exact details from that stored meaning, it doesn't retrieve them directly, because they were never fully stored to begin with. Instead, it generates details that fit the gist, plausible, consistent, reasonable details that may or may not match what actually occurred. There's a well-established framework in memory science that explains this particular process with real precision. Fuzzy trace theory explains false memories as a split between verbatim details and the gist, or meaning, of an event. According to this theory, every experience creates two separate kinds of memory traces, forming at the same time, but behaving quite differently from each other. The verbatim trace holds the specific, exact details, the precise words, the specific colors, the literal sequence of events. The gist trace holds something looser, and in many ways, more durable, the overall meaning, the emotional tone, the general shape of what happened. Verbatim traces, researchers have found, tend to fade relatively quickly. Gist traces tend to last much longer. Which means that as time passes, you're increasingly left with the meaning of an experience, without the precise scaffolding of details that originally supported it. And when your mind is asked to recall those missing details, it doesn't simply admit they're gone. It reconstructs something that fits the gist, smoothly, convincingly, and often, without any accompanying sense of uncertainty. This gap between meaning and detail turns out to be one of the most consistent sources of false memory across all of memory research. Now, something even more surprising. This distortion doesn't only happen afterward, during recall. In some cases, it begins far earlier than that, before a memory is even fully formed. Expectations can shape early memory traces, so people are more likely to remember what they predicted than what they actually saw. This is a striking idea, worth letting settle for a moment. Your mind doesn't experience the world as a completely blank, neutral observer. It's constantly predicting, based on patterns, context, and prior experience, what is likely to happen next. And these predictions, remarkably, can influence what gets encoded into memory in the first place, sometimes even more strongly than the actual sensory information arriving in that moment. If you expect to see something a certain way, your mind may partially fill in that expectation, blending it with the real, incoming information, before the memory has even finished forming. The result, later, is a memory that reflects, in part, what you anticipated, not simply what was objectively in front of you. And this process can begin astonishingly early in the chain of memory formation. Short-term memory can already be biased by expectation, meaning false memory processes can begin before a memory is even fully stored. This tells us something important. False memory isn't only a problem of long-term recall, occurring years after an event. It can begin within seconds, as an experience is still being processed and encoded for the very first time. Expectation quietly shapes perception. Perception shapes what gets encoded. And what gets encoded becomes the foundation for everything remembered afterward. In a very real sense, some memories are subtly incomplete, or subtly altered, from the very moment they're born, long before any retelling, any suggestion, any passage of time has had the chance to influence them further. Researchers have studied this pattern using something surprisingly simple, unfamiliar shapes, designed to test how the mind handles new, ambiguous information. Pseudoletters and other unfamiliar stimuli can trigger false perceptual memories when they resemble known patterns. Imagine being shown a shape that isn't quite any letter you recognize, but which resembles, faintly, letters you already know well. Later, when asked whether you'd seen that exact shape before, there's a strong tendency to mistakenly recall having seen a familiar letter instead, one the unfamiliar shape merely resembled. This happens because your mind, when faced with ambiguous or unfamiliar information, instinctively reaches for the closest known pattern, and quietly uses that pattern to interpret, and later recall, the experience. It's not a failure of perception. It's simply the mind doing what it always does, making sense of the unfamiliar, by relating it to what it already knows. This tendency toward pattern and connection appears in other, subtler forms as well. Other distortions can come from meaningless associations, where unrelated information gets linked in memory. Sometimes, two pieces of information become connected in memory for no meaningful reason at all, simply because they occurred close together in time, or were encountered in a similar context. A song playing in the background during an unrelated event. A stranger's face, present in the room during a completely separate conversation. Over time, these incidental associations can strengthen, until the mind begins treating them as though they were meaningfully connected, even though the original link was arbitrary, or entirely coincidental. And this associative quality of memory connects to something even broader, the way the mind sometimes prioritizes general patterns over the specific details of any one particular moment. Some maladaptive distortions come from overgeneralization, where broad patterns are remembered instead of exact episode-specific details. If you've had many similar experiences, countless ordinary mornings, for instance, or many similar conversations with the same person, your mind may begin to store a kind of composite version, a general template, rather than preserving each individual instance separately. This is often useful. It allows for quick, efficient understanding of familiar situations. But it also means that specific details from one particular morning, or one particular conversation, can blend into the broader pattern, becoming difficult to distinguish from all the others. You may recall the general shape of many similar events with confidence, while the specific, individual moment you're trying to remember quietly dissolves into that larger, blended pattern. Now we turn to something that adds a particularly powerful ingredient into this entire process: emotion. Emotion and mood can influence memory distortion, with arousal and mood-congruent processing affecting whether details are remembered accurately. Strong emotional states, whether excitement, fear, sadness, or anything in between, don't simply color how a memory feels. They can genuinely change what gets encoded, and what gets recalled later. Mood-congruent processing describes the tendency for people to more easily remember information that matches their current emotional state. When you're anxious memories may surface more readily. When you're calmer, gentler memories may rise more naturally to the surface. This means the emotional lens you're looking through, in any given moment, can quietly shape which parts of the past feel most accessible, and which parts, ironically, seem to fade into the background. Researchers have studied this particular relationship between emotion and memory distortion quite closely. Research on emotion-induced distortions shows that emotional arousal can change how false memories are encoded and retained. Heightened emotional arousal, whether positive or negative, tends to narrow attention toward the central, emotionally significant elements of an experience, while peripheral details often receive less attention and are more easily lost or later reconstructed inaccurately. This is why people often recall the emotional core of a significant event with striking clarity, while the surrounding details, the exact time, the specific sequence, the minor particulars, remain far more prone to distortion. And finally, something worth sitting with carefully, as we approach the end of this segment. False memories may become more vivid over time, even when they are inaccurate, which can make them harder to challenge later. You might expect that a false memory, being fundamentally untrue, would naturally weaken or fade with time. But research suggests the opposite can occur. Through repeated recall, through emotional reinforcement, through the quiet reconstructive editing we've explored throughout tonight, a false memory can actually grow more vivid, more detailed, more emotionally convincing, the more it's revisited. This means vividness alone, that rich, sensory, deeply felt quality a memory carries, is not reliable evidence of truth. Sometimes it simply reflects how often, and how vividly, a memory has been reconstructed, rather than how faithfully it reflects what actually occurred. We're gathering, piece by piece, a fuller picture now, gist and detail, splitting quietly apart. Expectation, shaping memory before it even fully forms. Emotion, narrowing focus toward what feels most significant, while everything else drifts. And vividness itself, growing stronger over time, independent of whether the memory is even true. In the next set of facts, we'll turn toward the specific research and the specific moments in scientific history when these patterns were first uncovered in careful, deliberate detail, and what those discoveries revealed about memory, testimony, and the delicate boundary between what happened and what only feels like it did. For now, let your mind rest here a while, in the quiet understanding that even the most vivid, richly detailed memories carry no guarantee of perfect truth, and that this doesn't diminish them. It simply means they are, like everything about being human, wonderfully and imperfectly alive. Let's move now from the shape of these distortions into the deeper architecture of when, exactly, they take root. Because false memories don't appear at just one single moment in the life of a memory. They can enter the story at several different points along the way, each one distinct, each one worth understanding on its own. False memories can be formed during encoding, consolidation, or retrieval, so there are multiple stages where errors can enter. Think of memory not as a single event, but as a process, unfolding across time, in three broad stages. Encoding, the initial moment an experience is taken in and translated into a memory trace. Consolidation, the period afterward when that fragile trace gradually stabilizes and becomes more durable. And retrieval, the moment, sometimes years later, when the memory is pulled back into conscious awareness. Each of these stages operates through its own mechanisms, and each one, it turns out, offers its own particular doorway through which distortion can enter. Memory errors can happen during encoding, consolidation, or retrieval, so false memories can enter at multiple stages. This is worth sitting with, because it means there is no single moment where memory is either perfectly safe or hopelessly vulnerable. Vulnerability exists throughout the entire process, from beginning to end. A distortion introduced early, during encoding, might already be present before consolidation even begins. And a memory that formed accurately at first can still be reshaped later, during retrieval, long after the original experience has passed. Let's walk through each stage a little more slowly, beginning with the very first moment a memory is born. During encoding, processes like imagery and self-referential thinking can increase the chance of false memories. This may seem, at first, a little counterintuitive. Imagery and self-referential thinking, imagining a scene vividly, or relating information back to yourself personally, are actually powerful tools for learning. They tend to make information more memorable, more meaningful, easier to hold on to over time. Teachers and researchers often encourage exactly these techniques to strengthen memory and understanding. But that same power comes with a quiet trade-off. When you form a vivid mental image of something, or connect new information closely to your own personal experience, you are, in a sense, actively constructing part of that memory in your mind, rather than passively absorbing it. And anything actively constructed carries a slightly higher risk of blending real information with imagined or inferred details, right from that very first moment of encoding. Once a memory has been encoded, it doesn't immediately become fixed and permanent. It enters a period of vulnerability, a window of time during which the brain works to stabilize it. Memory consolidation is often described as taking about 8 to 12 hours after learning, before the memory becomes more stable. During this window, the newly formed memory trace exists in a delicate, somewhat fragile state. It hasn't yet been fully integrated into the brain's longer-term storage systems. This isn't a flaw in the system. It's simply part of the natural timeline that memory formation follows, a gradual process, rather than an instant one. Memory consolidation is often described as taking 8 to 12 hours, which is one reason newly learned information can remain fragile for a while. This fragility has real, practical implications. During this consolidation window, a memory is more susceptible to interference, more easily reshaped by new information encountered in the hours that follow the original event. This is part of why the period immediately after an experience, the conversations that happen afterward, the information encountered in that same day, can carry a disproportionate influence over how that memory ultimately settles and stabilizes. At a biological level, something remarkable is happening during this window, quietly, at the level of individual brain cells. During consolidation, protein synthesis helps stabilize memory traces, meaning false information can interfere with that stabilization process. Deep within the neurons involved in forming a new memory, the process of protein synthesis works to physically strengthen and stabilize the connections that represent that memory, turning a fragile, temporary trace into something more lasting and secure. It's a beautifully intricate biological process, unfolding silently, without any conscious awareness on your part. But because this stabilization process is still underway, and not yet complete, it remains susceptible to disruption. If false or misleading information enters during this window, it doesn't simply sit alongside the original memory as a separate, competing version. It can become woven directly into the very process of stabilization itself, incorporated into the memory trace as it solidifies, rather than added afterward as an obvious addition. This vulnerability becomes especially interesting when we consider something we all experience every single night. During consolidation, sleep-related semantic generalization and misleading post-event information can reshape what is remembered. Sleep, it turns out, plays an active, meaningful role in how memories are processed and consolidated. During sleep, the brain doesn't simply preserve the day's experiences exactly as they occurred. It works through them, replaying and reorganizing certain patterns, strengthening some connections while allowing others to fade. Part of this process involves what researchers call semantic generalization, the tendency for the meaning and broader pattern of an experience to become reinforced during sleep, sometimes at the expense of the specific, exact details. Sleep-related semantic generalization can contribute to false memories by strengthening the gist of an experience, rather than the exact details. This connects beautifully back to fuzzy trace theory, which we explored earlier. If sleep tends to favor consolidating the gist of an experience over its precise details, then the passage of a single night's rest may already be quietly shifting the balance of a memory, reinforcing its general meaning, while allowing some of its finer, more specific details to soften and fade. This is simply part of how a healthy, adaptive memory system prioritizes information, favoring broader understanding over pure detail retention. Now we arrive at the final stage in this three-part process, the moment a memory is retrieved, brought back into conscious thought, sometimes long after the original event has passed. During retrieval, monitoring processes help reject false memories, so weak monitoring can make errors more likely. When you recall something, your mind doesn't simply accept whatever surfaces without any evaluation. There's an internal monitoring process at work, quietly checking incoming memories for signs of plausibility, consistency, and source accuracy. This monitoring system helps filter out details that don't quite fit, gently rejecting information that seems, upon closer inspection, unreliable or out of place. But this monitoring process isn't infallible. It can be weakened by fatigue, by stress, by divided attention, or simply by the inherent difficulty of evaluating information that feels just as vivid and convincing as any accurate memory. When monitoring is weaker, false details are more likely to slip through unchallenged, accepted into the final, reconstructed memory without ever being flagged as questionable. And this brings us to a final, important idea, one that reframes everything we've explored so far tonight in a slightly different light. Memory updating can sometimes be beneficial, but when incorrect or irrelevant information gets incorporated, it becomes a maladaptive distortion. It's worth pausing here, because everything we've discussed tonight can sound, on the surface, like a story about failure, about a memory system that simply doesn't work as well as we'd like it to. But that's not quite the full picture. The ability to update memories, to revise them in light of new information, is often genuinely useful. It allows understanding to grow, to adapt, to stay current with new knowledge and changing circumstances. The trouble arises only when the information being incorporated is incorrect or irrelevant, distorting the memory rather than refining it. The underlying mechanism, this openness to revision, this willingness to update, is the very same mechanism in both cases. It simply depends on what kind of information happens to arrive, and when. So here we find ourselves, resting for a moment at a fuller, richer understanding. Encoding, shaped by imagery and self-reference. Consolidation, stretching across those quiet 8 to 12 hours, vulnerable to interference, softened further by the gentle generalizing influence of sleep. And retrieval, guarded imperfectly by monitoring processes that can strengthen or weaken, depending on the moment. 3 stages. 3 doorways. And running through all of them, one continuous thread, a memory system built not for perfect preservation, but for flexible, adaptive understanding. In the next set of facts, we'll turn towards specific research in real-world contexts where these principles have been studied closely, and what they reveal about memory in situations where accuracy matters most. For now, let your thoughts settle here a while, resting in the quiet knowledge that your mind was never meant to be a vault, sealed and unchanging. It was built to be alive, shifting gently with each new day, each new understanding, each quiet night of sleep, carrying you forward, imperfectly, and remarkably, all the same. We ended our last chapter resting on the idea that memory was never meant to be a vault. And now, we turn toward one of the most elegant explanations for exactly why that's true, a process that reveals memory not as something fixed after formation, but as something capable of reopening, again and again, long after it first took shape. Memory distortion can sometimes be a side effect of the brain's normal ability to update old memories with new information. This is a gentle but important reframing. So much of what we've explored tonight can sound like malfunction, like error, like something going quietly wrong beneath the surface. But updating, the capacity to revise what you know in light of new circumstances, is not a flaw. It's a feature. It's one of the reasons human memory is so remarkably adaptive, so capable of keeping pace with a world that never stops changing. Distortion, in many cases, is simply the shadow side of that same useful ability, an occasional cost that comes bundled together with a genuinely valuable trait. Not all memory updating is bad. Correct updates can help memories stay aligned with current circumstances. Imagine learning that a friend has moved to a new address. Your memory of where they live needs to update, or you'd be left, indefinitely, with an outdated map of the world. Imagine learning new information that corrects an earlier misunderstanding. Your memory benefits from folding that correction in. This kind of updating is healthy. It's necessary. It keeps your internal model of the world accurate, current, and useful. The challenge only arises when the same mechanism that allows for these helpful, accurate updates also leaves the door open for incorrect information to slip through, unnoticed, using that very same pathway. And this leads us to one of the more fascinating discoveries in modern memory science, a process called reconsolidation. Reconsolidation happens when a retrieved memory becomes unstable again, which creates a window where it can be changed. For a long time, the assumption was that once a memory had been fully consolidated, stabilized in the ways we explored earlier, it remained permanently fixed from that point forward. But research revealed something more delicate and more dynamic than that. When a stored memory is retrieved, brought back into active, conscious thought, it doesn't simply get read out like a file being opened and closed again untouched. In many cases, the act of retrieval seems to temporarily destabilize the memory, returning it, briefly, to something resembling its earlier, more fragile state. This means the past is not sealed shut once it's been stored. Every time you consciously recall something, you may be quietly reopening it, just a little. Reconsolidation can make a recalled memory temporarily fragile, allowing new false information to become integrated into it. This is a strange and quietly profound idea. It means the very act of remembering something, revisiting it in your mind, isn't necessarily a purely passive experience. It can create a brief window of vulnerability, during which new information present in that moment, accurate or not, has an increased opportunity to blend into the memory, becoming woven into it as it settles back down into storage once again. During reconsolidation, a reactivated memory becomes fragile again, which can allow false information to be integrated into it. Think about what this means practically. If you recall an old memory while in conversation with someone else, and that person mentions a detail slightly differently than you remember it, there's a window, during that very act of recalling, where their version has a genuine chance to blend into your own. Not because you're careless, or easily persuaded. Simply because reconsolidation briefly reopens the door. False memories can arise from reconsolidation, when a recalled memory becomes temporarily malleable, and new information gets integrated into it. This process, researchers believe, may be one of the most significant, ongoing sources of memory distortion across a person's life. Not a single dramatic moment of suggestion. Not one isolated instance of imagination running further than intended. But a slow, repeated pattern, occurring quietly every time an old memory gets revisited, reopened, and gently reshaped, before settling back into storage once more. This naturally leads us into a closely related concept, one that's been studied extensively over the decades: the influence of information encountered after an event has already occurred. Post-event misinformation can alter a memory after the original event has already happened. This describes situations where, following a genuine experience, a person is later exposed to information that's inaccurate, whether through a leading question, a mistaken account from someone else, or simply an assumption stated as though it were fact. That inaccurate information doesn't simply exist alongside the real memory, as a separate, competing account. Given the right conditions, it can actually become absorbed into the memory itself, changing how the original event is recalled from that point forward. And there's an important nuance researchers have identified about exactly when this influence tends to be strongest. Misinformation is more likely to alter memory when it is encountered before retrieval, not just after the original event. This distinction matters. It's not simply about how much time has passed since the original experience. It's about the relationship between when the misinformation arrives, and when the memory is next actively recalled. If misleading information is encountered shortly before someone is asked to remember an event, that timing appears to create a particularly vulnerable window, potentially connecting back to the reconsolidation process we just explored, where retrieval itself opens a door through which new information, true or false, can enter. And once that misinformation has successfully made its way in, it doesn't remain a one-time, isolated event. It can echo forward, influencing memory again and again. once misinformation gets integrated, it can continue to influence later memory judgments through the continued influence of the misinformation effect. This means a single instance of inaccurate information, absorbed once into a memory, doesn't simply fade quietly afterward. It can continue shaping how that memory is recalled in the future, again and again, each time reinforcing itself a little further, each time feeling a little more natural, a little more certain, a little more like it always belonged there. This is part of why correcting a false memory, once it has taken hold, can be so difficult. It's not simply a matter of providing accurate information. The false detail may already be functioning as though it were part of the original, authentic memory, deeply embedded, rather than sitting loosely on the surface, easily lifted away. And finally, something that reveals just how remarkably fast this entire process can unfold, faster, perhaps, than most people would ever imagine. The brain may create false memories faster than expected, with some studies showing illusory memory formation within half a second. Half a second. Let that number settle for a moment. We often imagine false memories forming gradually, over days, weeks, or years, shaped slowly by suggestion, imagination, and time. And often, that gradual process is exactly what happens. But some research suggests that under the right conditions, the earliest traces of a false memory can begin forming almost instantly, within a fraction of a single second, as the brain rushes to interpret and categorize new information, sometimes reaching for a familiar, related pattern before fully registering the specific, accurate details of what's actually in front of it. This tells us something quietly humbling about the mind. The line between perceiving something accurately and beginning to misremember it isn't always a long, slow journey. Sometimes, it's nearly instantaneous, woven into the very first moments of how an experience is processed, long before any suggestion, any retelling, any passage of time has had the chance to play its part. So here we rest, for a moment, with a fuller, richer understanding taking shape. Updating, a healthy and necessary process, carrying within it a quiet vulnerability. Reconsolidation, reopening old memories every time they're recalled, if only briefly. Misinformation, capable of slipping through that open door, especially just before retrieval, then echoing forward through every future recollection. And underneath all of it, a mind capable of beginning this entire process in less time than it takes to blink. None of this should feel alarming. If anything, let it feel like a quiet unveiling, a closer look at the intricate, constantly moving machinery that has been working, faithfully and imperfectly, behind every memory you've ever carried. In the next set of facts, we'll turn toward the real world, toward specific situations, professions, and circumstances where these processes carry consequences that reach far beyond the quiet privacy of a single mind. For now, let yourself rest here a while longer, in the soft, unhurried dark, where the boundary between what happened and what merely feels remembered grows pleasantly, harmlessly blurred, and where there's nothing you need to hold on to tightly tonight, except the gentle rhythm of your own breathing, carrying you closer to sleep. We've spent this evening moving slowly through the psychology of false memory, the patterns, the processes, the quiet mechanisms happening beneath conscious awareness. Now, we turn somewhere a little different. Somewhere deeper, in a literal sense. into the brain itself, into the actual neural tissue where these processes physically unfold. Some research suggests false memories can arise very quickly, even within seconds, under the right conditions. We touched on this briefly before, with that striking half-second finding. But it's worth returning to, because it sets the stage for everything we're about to explore. If false memories can begin forming almost instantly, then somewhere in the brain, in real time, there must be a physical, measurable process responsible for that speed. And thanks to modern neuroimaging, researchers have actually been able to watch, in remarkable detail, where and how that process unfolds. Laboratory studies have shown that false memories can emerge very rapidly, even within seconds, or a few seconds, under some conditions. This consistency across multiple studies matters. It tells us this isn't a rare anomaly, or a strange one-off result. It's a reproducible pattern, observed again and again, under carefully controlled laboratory conditions. Which means, somewhere in the brain's ordinary architecture, there exists a built-in capacity for extremely fast memory distortion, a feature of the system itself, rather than a rare glitch. And when researchers looked closely, using brain imaging technology, at what was happening during exactly these moments, they found something quite specific. In one neuroimaging study, activity in the left hippocampus tail and parietal cortex was correlated with encoding, even when the resulting memory was false. Let's slow down here, because these are unfamiliar terms for many listeners, and they deserve a gentle unpacking. The hippocampus is a small, curved structure deep within the brain, long known to play a central role in forming new memories. The parietal cortex sits nearby, closely involved in recognizing whether something feels familiar. Together, these regions form part of the brain's core memory processing system. What's remarkable about this particular finding is that these regions showed activity during encoding, during the very moment information was being taken in, regardless of whether the resulting memory turned out to be accurate or false. In other words, from the brain's perspective, in that initial moment of encoding, a true memory and a false memory can look remarkably similar. The neural machinery doesn't necessarily know, in advance, which kind of memory it's building. This idea deepens further when we look at a related, and equally revealing line of research. Neuroimaging studies show that activity in the hippocampus and parietal cortex during encoding can predict whether a later memory will be true or false. This is a particularly elegant piece of research, worth sitting with for a moment. Researchers found that by observing brain activity in these specific regions, during the moment of encoding, they could actually predict, with meaningful accuracy, whether a person would later recall that information correctly or incorrectly. This means the seeds of a false memory can sometimes be detected, physically, in the brain, before the person themselves has any conscious idea that anything has gone astray. There's something quietly humbling in that. Long before you ever try to recall an event, and long before any suggestion or misinformation has entered the picture, the earliest neural fingerprints of accuracy, or inaccuracy, may already be present, quietly forming, beneath the surface of conscious experience. As researchers expanded their focus beyond just these two regions, a broader picture began to take shape. The hippocampus and several cortical regions have been linked to false recognition in neuropsychology and neuroimaging research. False recognition, that familiar feeling of having seen or experienced something before, when you actually haven't, doesn't appear to arise from a single, isolated brain area working alone. It emerges from a broader network, the hippocampus working alongside several regions of the cortex, the brain's outer layer, responsible for higher-level processing, integration, and interpretation of experience. This tells us something important about the nature of memory itself. It was never really housed in one single place. It has always been a distributed, collaborative process, involving multiple brain regions working together, each contributing its own particular piece to the final, reconstructed whole. And as research techniques have grown more sophisticated, scientists have continued mapping out just how far this network extends. False memory research links several brain systems, including the medial temporal lobe and the medial and lateral prefrontal cortex. The medial temporal lobe, which includes the hippocampus and surrounding structures, has long been recognized as central to memory formation. But the prefrontal cortex, the region at the very front of the brain, associated with reasoning, judgment, and higher-level thinking, also plays a significant, active role. This suggests that false memory isn't simply about how information gets stored. It's also deeply connected to how that information gets evaluated, interpreted, and ultimately judged as true or false, once it resurfaces. Even broader networks have been implicated in this process, including one that might surprise you. The default mode network, the prefrontal cortex, and the hippocampus are all implicated in how memories are selectively reconstructed. The default mode network is a set of brain regions that tend to become active during quiet, internally focused states, daydreaming, imagining, reflecting, mind-wandering. It's often associated with the brain's spontaneous, self-generated activity, rather than direct, external perception. Its involvement in memory reconstruction is a fascinating detail, because it suggests that the same neural systems responsible for imagination, and for the wandering, associative thoughts that drift through your mind during quiet moments, may also play a meaningful role in how memories get rebuilt, and sometimes subtly altered, each time they're recalled. This connects beautifully back to something we explored earlier tonight, the idea that imagination and memory share overlapping neural territory. Here, in the architecture of the brain itself, we find a physical, structural explanation for exactly why that overlap exists. Now, let's turn toward a particularly hopeful piece of this larger puzzle, the brain's own internal safeguards, working quietly to catch and correct these very distortions. The prefrontal cortex helps with retrieval monitoring, which can reduce false recognition. Remember the internal monitoring process we discussed earlier, the quiet mental checkpoint that evaluates incoming memories for plausibility and accuracy. Neuroimaging research suggests the prefrontal cortex plays a significant role in exactly this function. When a memory is retrieved, this region appears to help evaluate it, weighing its details, checking its consistency, and in many cases, successfully filtering out distortions before they're consciously accepted as accurate. This means your brain isn't a passive victim of its own reconstructive tendencies. It has built-in defenses. Quiet, imperfect, but genuinely present, working to protect the accuracy of what you remember. And this protective role extends even further back, into the earliest moments of memory formation. The prefrontal cortex appears to support source encoding, meaning it helps store the context in which information was learned. This connects directly back to source monitoring, something we explored earlier tonight. Remember that internal tagging system, responsible for labeling each piece of information according to where it came from, direct experience, imagination, or something you were simply told. The prefrontal cortex appears to be deeply involved in creating and maintaining exactly this kind of contextual tagging, right from the moment information first enters memory. When this system functions well, it provides a strong foundation, helping ensure that memories remain properly linked to their true origin, long into the future. But like any system, this one has its own particular vulnerabilities, and researchers have identified one especially telling pattern. Weak prefrontal activity during misinformation exposure has been linked to a greater chance that false details get embedded into the original memory. This finding brings together nearly everything we've explored tonight in a single, elegant conclusion. When the prefrontal cortex is less active, less engaged, during a moment when misleading information is present, that misinformation appears to have a significantly easier path toward becoming woven into the original memory. The very system responsible for monitoring, evaluating, and protecting memory accuracy, when quieter than usual, simply lets more through. This might happen during moments of distraction, fatigue, divided attention, or reduced cognitive engagement. It's a gentle, important reminder that the mind's defenses against false memory aren't fixed and constant. They shift, moment to moment, depending on how alert, how present, how engaged your mind happens to be, at any given time. So here we find ourselves, resting in a quieter, deeper layer of understanding tonight. Beneath every psychological pattern we explored earlier, the gist and the detail, the imagination and the suggestion, the reconsolidation and the misinformation, lies a physical, biological reality. Small structures, deep within the brain. The hippocampus, quietly forming new memories, sometimes true, sometimes false, often before you're even aware a memory is forming at all. The prefrontal cortex, shaping that early sense of familiarity. The prefrontal cortex, standing watch, monitoring, evaluating, protecting, though never perfectly. In the default mode network, weaving imagination and memory together, in the same soft, wandering neural space. None of this is separate from who you are. It's simply the quiet, physical machinery beneath every memory you've ever held, every story you've ever told about your own life, every moment you've ever looked back and said, "I remember this." In the next set of facts, we'll move gently beyond the brain itself, into the real-world places where all of this comes to matter most, in ways that reach far beyond a single, private mind. For now, let your thoughts rest quietly here, somewhere deep beneath conscious awareness, in the soft folds of the hippocampus, in the slow, steady rhythm of neurons working patiently through the night, doing, even now, exactly what they have always done, gently, imperfectly, faithfully, carrying you forward. We left off deep in the folds of the brain, resting in the quiet machinery of memory formation. Let's continue there a while longer, because there's more this particular thread has to offer, more detail waiting, patiently, in the space between neuroscience and lived experience. Weak prefrontal cortex activity during exposure to misinformation has been linked to poorer source encoding and more false memories. This builds directly on what we explored before drifting toward sleep. When the prefrontal cortex isn't fully engaged during a moment when misleading information arrives, two things seem to happen together. Source encoding weakens, meaning the origin of that information becomes harder to properly tag and remember. And false memories become more likely to take hold. These aren't two separate problems happening side by side. They appear to be closely connected, two expressions of the very same underlying vulnerability. And this vulnerability doesn't only appear once, quietly, in a single moment of exposure. It can resurface later, in an entirely different context, the moment a memory is actually tested, questioned, or recalled. During testing, misinformation can compete with original information inside the hippocampus, helping produce a false recollection. Picture two versions of an experience, existing somewhere within the hippocampus, side by side. One reflects what actually happened. The other reflects the misleading information that was absorbed sometime afterward. When you're later asked to recall the event, these two versions don't sit peacefully apart from each other. They seem to compete, actively, for the position of being recognized as the real memory. And depending on a range of factors we've discussed throughout the night, source monitoring, prefrontal engagement, the vividness of each version, either one might win out. This is a strangely poignant image, in its own quiet way. Somewhere inside your own hippocampus, competing versions of the past may occasionally exist together, waiting to see which one will be called forward the next time memory is asked to speak. Researchers have also identified another brain region playing a specific, meaningful role in this larger story. The temporal pole's semantic representations have been shown to predict false memories in some neuroscience studies. The temporal pole is a region located near the front of the temporal lobe, closely involved in processing meaning, connecting specific experiences to broader categories, concepts, and general knowledge. Its involvement here connects beautifully back to fuzzy trace theory and the idea of gist-based memory. If the temporal pole helps represent the broader meaning of an experience, then its activity, researchers have found, can actually help predict whether a later memory will be accurate or distorted. Meaning, once again, showing itself as one of the central threads running through nearly everything we've explored tonight. Some of the clearest evidence for how false memories physically form has come, interestingly, not from human studies alone, but from research conducted with animals. Animal research has suggested that false memories may involve the simultaneous activation of true memory and false memory neural networks. In these studies, researchers have been able to observe, quite directly, the neural circuits involved when an animal experiences a genuine memory alongside conditions that produce a false one. And what they've found is striking. Rather than one network simply replacing the other, both networks, the one representing the true experience, and the one representing the false, incorrect information, can become active together, at the same time, layered over each other rather than existing entirely apart. This offers a remarkably vivid picture of what may be happening during many of the distortions we've discussed tonight. Not a clean substitution, one memory replacing another, but an overlapping, simultaneous activation, true and false, momentarily present together, before the brain settles on which version will ultimately be carried forward. And that settling process, researchers suggest, may involve something quite specific. Some researchers describe false memory as a single network, formed after true and false traces are jointly activated and then reconsolidated. This is a beautiful, if slightly bittersweet, way of understanding what may be happening at a neural level. If true and false information become active together, and then undergo reconsolidation, that process we explored earlier tonight, they may not simply remain as two separate, competing threads. They can become woven together into a single, unified memory trace, one that carries elements of both, no longer clearly separable into true and false components, but blended into something new entirely. This helps explain something we touched on earlier, why false memories so often contain a mixture of real and invented details, rather than being purely one or the other. At a neural level, this may be less like removing a section and replacing it with something false, and more like weaving two different threads into a single strand, from that point onward, indistinguishable from each other in the final result. It's worth pausing here to gently emphasize something important. False memories are not always random errors. Some arise from specific interactions between sensory, memory, and executive brain systems. This is a meaningful distinction. It would be easy to imagine false memories as simply chaotic, unpredictable glitches, occurring at random, without any discernible pattern. But research increasingly shows something more structured than that. Specific brain systems, sensory regions, responsible for the initial input of an experience, memory systems, responsible for encoding and storage, and executive systems, like the prefrontal cortex, responsible for monitoring and evaluation, interact with each other in particular, patterned ways. And false memories often emerge from specific breakdowns, or specific overlaps, within those interactions, rather than from pure randomness. This structured quality is part of what has made false memory such a fruitful, rewarding subject for scientific study. In misinformation studies, brain activity during the original event and during exposure to misleading information can differ depending on whether a false memory forms. Researchers have found that by comparing brain activity at these two distinct moments, during the original experience itself, and later, during exposure to misleading information about that experience, they can often identify meaningful differences, depending on whether a false memory ultimately takes hold, or not. This offers yet another layer of insight into a question we touched on earlier tonight, the idea that the seeds of memory distortion can sometimes be detected, physically, before the person themselves consciously realizes anything has gone astray. Now, let's turn toward the person whose name has become almost synonymous with this entire field of study. Researchers like Elizabeth Loftus have shown that memory can be altered, and in some cases, false memories can be induced. Over several decades, this line of research helped transform how psychologists, and eventually the wider public, understood the reliability of human memory. Through carefully designed studies, researchers demonstrated that memory isn't simply vulnerable to distortion by accident, under rare or unusual circumstances. Under the right conditions, false memories, including memories of entire events, can genuinely be introduced, and, in some cases, come to feel just as real and convincing as memories of things that actually happened. This body of work laid much of the scientific foundation for nearly everything we've explored together tonight, and it opened the door to one of the most well-known experimental methods ever developed for studying false memory in a laboratory setting. The Dies-Roediger-McDermott paradigm, often referred to simply as the DRM paradigm, is a classic laboratory method for producing false memories of words that were never shown. The method itself is elegantly simple. Participants are shown a list of words, all closely related to a single, central theme, but the one word most directly representing that theme, the word tying everything together, is deliberately left out of the list entirely. Words like bed, rest, tired, dream, and pillow might appear, for instance, while the word sleep itself is never presented. And what happens next reveals something remarkable about the associative nature of memory. In DRM studies, people often falsely recall or recognize a critical word that fits the theme of the list they studied, even though that word was never actually shown. Time and again, when asked to recall the list, or later asked whether a specific word had appeared on it, participants frequently include this missing, central word, with just as much confidence, just as much subjective certainty, as they report for words that were genuinely presented. Their minds, guided by the powerful thematic and associative connections running through the list, quietly generate the missing piece, and then experience that generated piece as though it had been part of the original experience all along. This simple, elegant experiment has become one of the most widely used tools in all of false memory research, precisely because it demonstrates, cleanly and repeatedly, just how naturally, and how convincingly, the mind can construct a false memory, using nothing more than ordinary, everyday associative thinking. So here we rest again, a little deeper into the science than before. Competing traces within the hippocampus. Meaning represented in the temporal pole. True and false networks, activating together, then reconsolidating into something newly blended. Structured, patterned interactions across sensory, memory, and executive systems. Decades of careful research, tracing this story from its earliest scientific beginnings. And a simple, quiet laboratory experiment, using nothing more than a list of ordinary words, capable of gently, convincingly, creating a memory of something that was never there at all. In the next set of facts, we'll carry this understanding forward into places where these mechanisms carry real, lasting consequences, in courtrooms, in therapy, in the delicate space of human testimony and trust. For now, let your mind rest quietly here, drifting somewhere between what was said and what was only implied, between bed and rest and tired and dream, and that one quiet, missing word, waiting patiently at the edge of thought, for your mind to gently, naturally, fill in on its own. Let's continue with that same quiet word we ended on before, resting at the edge of thought, right where we left it. Because there's something important still to understand about it, something that takes us from the neural architecture we explored earlier, into the felt, subjective experience of the person actually living through it. false memories produced by the DRM paradigm can feel very similar phenomenologically to true memories. Phenomenologically, a gentle word, worth pausing on for a moment. It simply means, from the inside. From the felt, subjective, first-person experience of remembering. And what researchers have found, again and again, is that when someone falsely recalls that missing critical word, the experience doesn't feel diminished, or uncertain, or somehow lesser than an accurate memory. It can feel every bit as real, as vivid, as confidently held, as a memory of something that genuinely happened. This is a profound detail, because it means there is no reliable internal signal separating true memories from false ones. From the inside, in that private, personal space where memory lives, they can feel completely indistinguishable from each other. Because of this, researchers have needed to develop careful, thoughtful ways of studying false memory, methods that go beyond simply asking someone, "Do you remember this?" Researchers study false memories using both objective tests, like recognition and source memory, and subjective ratings of memory qualities. Objective tests might ask a person to identify whether a specific word or detail was actually presented earlier, providing a measurable, external check against what really happened. Subjective ratings, meanwhile, ask people to describe the quality of their memory, how vivid it feels, how much sensory detail accompanies it, how confident they are in its accuracy. By combining both approaches, researchers can compare what someone believes about their own memory with what can actually be verified as true, revealing the gaps between the two. And when researchers gathered together the results of many different studies, examining false memory across a wide range of conditions, a clear, consistent pattern began to emerge. A meta-analysis found that suggestive procedures can produce false memories in a substantial minority of participants, with rates varying by method. A meta-analysis, combining the results of many individual studies into one larger, more comprehensive picture, offers a particularly reliable form of evidence. And what this body of research consistently shows is that suggestion, in its many different forms, reliably produces false memories in a meaningful portion of the people exposed to it. Not everyone, but a substantial minority, with the exact numbers shifting depending on the specific method used and the conditions under which it was applied. This tells us something important. False memory formation isn't rare, or unusual, or limited to particularly susceptible individuals. It's a consistent, reproducible feature of ordinary human memory, present, to varying degrees, across a wide range of people and circumstances. Researchers have also identified which particular kinds of suggestion tend to be most effective at producing these false memories. Personalized suggestion is more effective at inducing false memories than merely presenting an event as plausible. There's an important difference between telling someone, generally, that a certain type of event is common, or believable, and crafting a suggestion that feels personally tailored to them specifically. When a suggestion includes personal details, references familiar people or places, or is framed in a way that feels individually relevant, it becomes significantly more persuasive, and more likely to be absorbed as genuine memory. This makes intuitive sense when we consider everything we've explored tonight. Self-referential thinking, we learned earlier, increases the likelihood of false memory formation during encoding. Personalized suggestion draws on that very same underlying vulnerability. Some of the more unusual, and perhaps unexpected, methods studied by researchers have shown particularly striking results. Dream interpretation and hypnosis can, in some studies, produce false belief induction in more than half of participants. This is a remarkable figure, worth sitting with for a moment. In certain experimental conditions, using dream interpretation or hypnosis as a vehicle for suggestion, researchers found that more than half of the people involved came to develop false beliefs about their own personal history. These techniques share a common thread. Both involve altered, relaxed states of focused attention, states in which the ordinary, vigilant monitoring processes we discussed earlier, the ones responsible for catching and rejecting inaccurate information, may become somewhat quieter, somewhat less active than usual. This doesn't mean dream interpretation or hypnosis are inherently harmful practices. It simply reveals, with striking clarity, just how much influence context and mental state can have over memory's ordinary defenses. Not every method, however, produces such high rates of false memory. And this next detail offers an important, balancing perspective. In one experimental work, only a fraction of people form false memories after just a very short exposure, showing that false memory creation can be rapid but not universal. This is worth holding alongside everything else we've explored tonight. Yes, false memories can form remarkably quickly, sometimes within seconds, as we discussed earlier. But rapid formation doesn't mean universal formation. Even under conditions specifically designed to encourage false memory, only some individuals, not everyone, actually develop one. This tells us that susceptibility genuinely varies, from person to person, and from moment to moment, shaped by individual differences in monitoring, attention, personality, and countless other quiet factors. The content of these false memories, researchers have also found, isn't limited to neutral, mundane details. It can extend into far more emotionally significant territory. Some laboratory procedures can produce both criminal and non-criminal emotional false memories, showing that the effect is not limited to neutral details. In certain carefully designed, ethically reviewed studies, researchers have successfully induced false memories involving emotionally significant events, including, in some cases, false memories of having committed a criminal act during adolescence, alongside other, non-criminal but still emotionally charged false memories. This reveals something important, and worth sitting with gently. False memory isn't confined to trivial, low-stakes details, like a missing word on a list. Under the right conditions, it can extend into deeply significant, identity-relevant territory, memories that touch on morality, on personal history, on the very story a person tells about who they are. This naturally leads us toward one of the most significant, real-world applications of everything we've explored throughout tonight. Eyewitness testimony can be vulnerable to false memory, which is one reason memory errors matter in legal settings. For much of legal history, eyewitness testimony was treated as some of the most powerful, persuasive evidence available in a courtroom. A person, standing before a judge or jury, confidently recounting what they saw, felt deeply convincing, almost unquestionable. But everything we've explored tonight reveals why that confidence, on its own, was never a reliable guarantee of accuracy. An eyewitness isn't immune to reconstruction, to suggestion, to the quiet blending of imagination and memory. They are simply a person, using the very same reconstructive memory system we've spent this entire evening exploring together. And researchers have identified very specific ways this vulnerability can be triggered, even unintentionally, through something as simple as the phrasing of a question. In eyewitness research, misleading wording in a question can increase later false recall of event details. This finding has been demonstrated repeatedly, across many different studies. The precise words used to ask about an event, whether a question implies a certain detail existed, or subtly suggests a particular version of what happened, can measurably shift what a witness later recalls, even when the underlying event itself never changes. A single word, altered slightly, phrased just a bit differently, can be enough to introduce a distortion, quietly, without the witness ever being aware that their memory is shifted at all. And finally, tonight, one more piece completes this particular part of the picture, the role that time itself plays in this vulnerability. The time gap between an event and being questioned about it can affect how vulnerable someone is to misinformation. This connects beautifully back to nearly everything we've explored throughout this entire evening. The longer the gap between an original event and the moment someone is questioned about it, the more opportunity exists for the natural fading we discussed earlier, for the softening of verbatim detail, for consolidation and reconsolidation to quietly do their work, and for outside information, encountered along the way, to blend gently into the original account. This is part of why the timing of an interview, or a question, matters just as much as its content. Both shape, together, how faithfully a memory can ultimately be recovered. So here we rest, once again, at the edge of something significant. False memories feeling just as real as true ones, from the inside. Suggestion, shaping memory more powerfully when it feels personal. Altered states, quieting the mind's own defenses. Susceptibility, varying gently from person to person. And beyond the walls of any laboratory, in courtrooms, in real human lives, these same mechanisms shaping something as consequential as testimony, and justice itself. In the next set of facts, we'll continue moving through these real-world implications, following this thread further into the delicate, deeply human spaces where memory, belief, and consequence meet. For now, let your thoughts rest here a while, unhurried, resting in the quiet understanding that even memory, in all its imperfection, still carries within it something worth honoring, the simple, remarkable fact that a mind can hold a moment at all, however imperfectly, however gently reshaped along the way. We left off in the space where memory meets consequence, in courtrooms and testimony. Let's continue there a moment longer, because there's a hopeful detail worth sitting with first. Immediate questioning after an event tends to reduce suggestibility compared with delayed questioning. This offers a gentle counterbalance to what we explored before drifting toward this segment. If the gap between an event and being questioned about it increases vulnerability, then it follows, naturally, that closing that gap can offer some protection. When someone is asked about an experience shortly after it occurs, before verbatim details have had much chance to fade, before consolidation has fully settled, before outside information has had time to quietly slip in, their account tends to remain closer to what actually happened. This is part of why investigators, researchers, and clinicians alike are often encouraged to gather information as soon as reasonably possible, rather than waiting. But timing, as it turns out, is only one piece of a much larger picture. Who is doing the questioning matters too, in ways that carry their own quiet weight. Directed questioning from authority figures, such as therapists or police, can contribute to false memory formation. There's something about the presence of authority, someone perceived as knowledgeable, trustworthy, or in a position of power, that changes how information is received. When a question comes from a figure like this, it tends to carry additional weight. A suggestion embedded within that question doesn't feel like a stranger's passing comment. It feels like something worth taking seriously, worth incorporating, worth trusting. And this added trust, ironically, can make a person more susceptible to absorbing inaccurate details, rather than less. This isn't a criticism of therapists, or investigators, or anyone acting in these roles. Most work carefully, with genuine care for accuracy. It's simply a reflection of how deeply human memory is shaped by social context, a theme that's about to become the center of our attention for a while. To understand this more fully, it helps to return to a framework we touched on earlier tonight, and look at it a little more closely. The source monitoring framework says we decide whether something is a memory based on its subjective qualities, our beliefs, and the social context. This is worth slowing down on. When your mind evaluates whether something feels like a genuine memory, it isn't relying on some perfect, objective test. It's weighing several different kinds of evidence together. The subjective qualities of the experience itself, how vivid, how detailed, how emotionally rich it feels. Your existing beliefs, about yourself, about the world, about what seems plausible or likely. And the social context surrounding that memory, who else was present, what others have said about it, how it fits into a shared, collective story. None of these factors, on their own, provide certainty. But together, woven into a single impression, they create that quiet, convincing sense of, yes, this happened, I remember it. The source monitoring framework says memory judgments depend on subjective qualities, prior beliefs, motives, goals, and social context. This expands the picture even further. Motives and goals, it turns out, also play a role. If accepting a particular memory as true serves some purpose, aligning with how you want to see yourself, supporting a relationship, resolving some internal tension, that motivation can quietly influence how readily the memory gets accepted, without any conscious awareness that this influence is even happening. This helps explain something we're about to explore in real depth, the profound, and sometimes underestimated, role that other people play in shaping what we remember. False memories can be influenced by the perceived confidence or trustworthiness of the person providing suggestive information. If a suggestion comes from someone who seems certain, sincere, and credible, it tends to carry far more influence than the exact same suggestion, delivered by someone who seems hesitant or unreliable. This makes sense, in a way. Trusting confident, credible sources is often a reasonable strategy for navigating the world. But it also means that confidence itself, in the person delivering information, can become a quiet vulnerability, a doorway through which inaccurate details slip in more easily, precisely because they arrive wrapped in the appearance of certainty. And here, we arrive at something particularly fascinating, a discovery that reveals just how social the process of memory distortion can actually be, extending even beyond simple suggestion. False memories can be socially induced even without explicit misinformation, if people co-monitor information while learning together. This is a subtle but important distinction. So far tonight, we've mostly discussed situations where someone actively provides false or misleading information. But this particular finding describes something quieter, and in some ways more surprising. Simply learning alongside another person, sharing an experience together, paying attention to what they seem to be noticing or focusing on, can shape memory, even without any false statement ever being made. Researchers have studied this directly, and found something quite striking. In one study, participants reported more false memories for words related to a partner's task than for control words, even though no deceptive information was communicated. Picture two people working together, each focused on a slightly different set of information. Even though no one said anything false, even though there was no attempt at deception whatsoever, participants later showed a tendency to falsely recall words connected to what their partner had been focused on, more than words entirely unrelated to either of their tasks. Simply being near someone, attending to the same shared space, absorbing subtle cues about what they seemed to be noticing, was enough to influence memory, quietly, without any explicit information being exchanged at all. This reveals something remarkable about the deeply social nature of human memory. It doesn't only respond to what we're directly told. It responds to the simple, ambient presence of shared attention. And this social influence isn't limited to small, laboratory details, like isolated words on a list. Socially induced false memories can occur for rich memories, not just simple word-list mistakes. This finding extends everything we've just discussed into more meaningful, more complex territory. Full, detailed, richly textured memories, involving entire scenes, entire experiences, can be shaped by social context in this same quiet way, not only simple, isolated pieces of information. This means that shared experiences, memories formed alongside family, friends, or partners, may carry a subtle social fingerprint, gently shaped by the people we experience them with, in ways far more intricate than simply, "They told me this happened." This social dimension of memory distortion has taken on a particular urgency in recent years, as the flow of information in daily life has changed dramatically. Fake news exposure can contribute to both false memories and false beliefs, showing that misinformation effects extend beyond laboratory settings. Everything we've explored tonight, largely drawn from carefully controlled laboratory studies, has clear, real-world relevance in an age of rapid, widespread information sharing. Exposure to false or misleading news stories doesn't only shape opinions, or beliefs, in some abstract, intellectual sense. It can genuinely alter memory itself, leading people to recall entire events, sometimes involving public figures or significant moments, that never actually occurred, in precisely the way they remember them, or perhaps didn't occur at all. And this leads us, finally tonight, to one of the most widely recognized, almost folkloric examples of this phenomenon, a pattern with a name most people have encountered at some point. The Mandela Effect is a popular example of many people sharing the same misremembered detail. Named after a widely reported, mistaken belief that Nelson Mandela had died in prison during the 1980s, when in fact he lived for many years afterward, this term has come to describe situations where large numbers of people, independently, share the exact same inaccurate memory. A misspelled logo, remembered as spelled differently. A movie line, recalled with different wording than what was actually said. A detail from childhood, shared identically by countless people who never knew each other. While the popular explanations for this phenomenon sometimes drift into more speculative territory, the underlying reality connects directly to everything we've explored tonight. Shared cultural context, common assumptions, similar gist-based reconstruction, and the quiet, associative patterns of human memory can lead many different minds, entirely independently, toward the very same distortion, not because reality has changed, but because human memory, shaped by shared culture and common cognitive patterns, tends to bend in strikingly similar directions. So here we rest, for a while, at the edge of something quietly profound. Memory, we've learned tonight, was never a solitary, private process, sealed away inside a single mind. It's deeply social, shaped by who asks the questions, and when. Shaped by trust, and confidence, and authority. Shaped, even, by simply sharing space and attention with another person, without a single false word ever being spoken. And sometimes, shaped so similarly across so many different minds, that an entire culture can come to share the very same gentle, quiet distortion. In the next, final segment of our journey together tonight, we'll draw all of these threads together, moving toward a quiet, closing understanding of everything memory truly is, and everything it teaches us about being human. For now, let your thoughts rest here, unhurried, in the soft, shared space between one mind and another, where memory, it turns out, was never entirely your own to begin with, but something gently held, and gently shaped, together. We've spent this long night moving outward, from a single reconstructed detail, through neurons and networks, into courtrooms and shared social spaces. Now, in this final stretch of our journey together, we turn inward again, towards something quieter, more personal. Toward the memories we build not from others' suggestions, but from our own minds, working alone. False memories can also be altered not only by external misinformation but also by autosuggestion, where people convince themselves an event really happened. Everything we've explored so far has often involved another person, somewhere in the process, a question asked, a detail mentioned, information absorbed from someone else entirely. But memory, it turns out, doesn't need another voice in the room to drift from what actually happened. Sometimes, quietly, without any outside influence at all, a person can shape their own memory, simply through the private, internal work of their own thoughts, returning again and again to an idea, until it settles into something that feels indistinguishable from genuine recollection. Studies on autosuggestion suggest people can create false memories by convincing themselves that imagined experiences actually happened. This connects beautifully back to something we explored earlier tonight: imagination inflation, the way picturing something vividly, repeatedly, can make it feel increasingly familiar over time. Autosuggestion takes this a step further. It isn't simply about imagining something and having it grow familiar by accident. It describes a more deliberate, internal process, someone turning an idea over in their mind, entertaining it, considering it, until, gradually, without any single dramatic moment of realization, they come to believe it as their own lived history. There's something worth sitting with here, gently. This isn't about dishonesty or deliberate self-deception in any harsh sense. It's simply the mind doing what we've watched it do all night, building meaning, filling gaps, reaching for coherence. Only this time, the process unfolds in complete privacy, without any outside voice guiding it at all. Not every false memory, though, begins from nothing, or purely from internal reflection. Many, researchers have found, begin with something real, external, factual, verifiable, before quietly gathering false details around that solid, genuine core. Some false memories are built from true details gathered from photos, eyewitness accounts, or media reports before false details are added. Picture someone piecing together an understanding of an event they only partially witnessed, or perhaps didn't witness firsthand at all. A photograph offers one fragment. A conversation with someone else who was present offers another. A news report fills in a few more pieces. Each of these sources is, individually, a legitimate piece of real information. But as the mind assembles them together into a single, coherent narrative, gaps inevitably remain, and the mind, ever resourceful, fills those gaps, quietly, with plausible details that may not be accurate, blending seamlessly with the genuine fragments surrounding them. The final memory that emerges doesn't feel like a patchwork, built from several outside sources plus a few invented details. It feels like one continuous, personally experienced event, whole, complete, and entirely one's own. To study experiences this rich, this emotionally layered, researchers have needed to move beyond simple laboratory tools like isolated word lists. False memories can be studied using rich emotional narratives, not only simple word recognition tasks. While the DRM paradigm we explored earlier remains an elegant, valuable tool, it captures something relatively small in scale, a single missing word, quietly inserted into memory. But human experience, and human false memory, often involves far more complex, emotionally significant material. Full stories, meaningful relationships, formative moments. To understand false memory in its fullest, truest form, researchers have developed methods for studying these richer, more textured narratives directly, and what they've found deepens everything we've discussed so far tonight. Researchers have found that people often struggle to tell whether a vivid emotional memory is true or false, just by looking at how real it seems. This finding echoes something we touched on earlier, but extends it into deeper, more consequential territory. When a memory carries genuine emotional weight, when it feels significant, meaningful, tied closely to personal identity, that emotional vividness doesn't function as a reliable marker of truth. If anything, it can make the memory feel more certain, more unquestionably real, precisely because it matters so much. The emotional intensity that makes a memory feel important is simply not the same thing as evidence that it accurately reflects what happened. Now, as we near the close of this long exploration together, something important, and quietly reassuring, emerges from more recent research, a gentle correction to how false memory itself has sometimes been understood and discussed. Recent research on false memories suggests that some claimed false memories may actually be partial true memories, or memories of real events in different details or contexts. This is a valuable nuance, worth holding carefully. Not every instance of a mismatched detail, or a slightly altered account, represents a fully invented, entirely false memory. Sometimes, what looks like a false memory is actually something more modest, and in its own way, more understandable, a genuine memory of something real, simply recalled with certain details changed, shifted, or placed into a slightly different context than where they originally belonged. This distinction matters, because it reframes the picture in a gentler light. Rather than imagining the mind as prone to constructing entirely fictional events out of nothing, this research suggests that many so-called false memories are closer to blurred photographs than blank pages filled in with pure invention, genuine experiences, captured imperfectly, rather than fabricated experiences, created from nothing at all. Researchers examining this question closely have found something further worth understanding. A new analysis argued that some people labeled as having false memories did not report an entirely false event, and often recalled only a few suggested details with confidence. This offers an important, careful correction to how false memory research is sometimes interpreted, or oversimplified. When someone is described as having formed a false memory, it doesn't always mean they've constructed an entirely fictional experience, whole and complete, from beginning to end. Often, what's actually happening is more limited, more specific, a person confidently recalling perhaps just one or two suggested details, layered onto a memory of an event that, in its broader shape, may still be substantially accurate. This is a more precise, more compassionate way of understanding the phenomenon. Human memory, even when imperfect, is rarely wholly detached from reality. It bends. It blends. It absorbs new material, at times. But it rarely invents, wholesale, from nothing. That said, researchers have identified certain distortions that go beyond simple detail-level errors, something considerably more unusual, worth understanding as we bring this exploration toward its close. Deep distortions are a newer type of false memory that involve illogical relations between memories, not just a wrong detail. This describes something structurally different from what we've explored throughout most of tonight. Rather than a single incorrect detail, blended smoothly into an otherwise accurate memory, deep distortions involve a kind of internal inconsistency, elements of a memory that don't logically fit together, that couldn't coexist in reality as remembered, yet are nonetheless held together, confidently, as though they formed a single, coherent experience. This represents one of the more intriguing frontiers of current memory research, a reminder that even after decades of careful study, memory continues to reveal new layers, new subtleties, new questions still waiting to be fully understood. As we settle into the final moments of this long night together, let's turn toward a perspective that reframes everything we've explored, one final time, not as a story of failure, but as a story of purpose. Adaptive memory distortion theories argue that some memory errors may exist because they support useful functions like future simulation and creativity. This is a beautiful thought to rest on, as our journey together draws to a close. Throughout tonight, we've explored countless ways memory can drift from perfect accuracy. But what if this drift isn't simply a cost, a limitation, an unfortunate side effect of an otherwise well-designed system? What if it's part of the design itself? Consider what it means to imagine your future, to picture how a conversation might unfold tomorrow, to plan for a challenge you haven't yet faced, to dream up something that has never existed before. All of these remarkably human capacities draw on the very same reconstructive machinery responsible for false memory. A mind built to remember with perfect, rigid accuracy might struggle to imagine anything beyond what it has already directly experienced. But a mind built to reconstruct, to blend, to fill gaps with plausible new material, that same mind becomes capable of creativity, foresight, and imagination, precisely because it was never locked into simply replaying an unchangeable past. And this leads us to one final, closing idea, one that gathers together nearly everything we've explored across this entire night. Memory inaccuracies can reflect an efficiency trade-off. The brain may sacrifice exactness to improve prediction and problem-solving. Perfect, verbatim memory, preserved in complete detail, would come at an enormous cost. It would require vast amounts of storage, vast amounts of neural resources, dedicated to holding onto information that, in most cases, isn't actually necessary for living a full, functional life. By favoring gist over detail, meaning over precision, your mind trades a small measure of accuracy for something considerably more valuable: efficiency, flexibility, and the remarkable capacity to use the past not simply as a record, but as a foundation for navigating everything still ahead. And so, here we are, at the quiet close of 100 facts, gathered gently together across a single, unhurried night. We began by learning that memory is not a recording, but a reconstruction, rebuilt, rather than replayed, each time you reach for it. We explored how confidence and accuracy can quietly diverge from each other, how imagination and memory share more common ground than most people ever realize, and how something as simple as a missing word on a list can reveal the deep, associative architecture running beneath every memory you hold. We moved into the brain itself, into the hippocampus and the prefrontal cortex, watching false memories form in fractions of a second, watching true and false neural traces activate together, then quietly merge into one. We followed memory through encoding, through consolidation, through retrieval, discovering that vulnerability exists not at one single point, but gently, continuously, throughout the entire process. We saw how deeply social memory truly is, shaped by trust, by authority, by the simple presence of another person nearby, paying attention to something slightly different than we were. We traced this understanding into courtrooms, into eyewitness testimony, into the real, consequential spaces where memory errors carry weight far beyond any single, private mind. And finally, tonight, we arrive somewhere unexpectedly gentle, the understanding that memory's imperfections may not be flaws to overcome, but features quietly woven into its very design. The same reconstructive process that occasionally leads us astray is the very same process that allows us to imagine, to create, to plan, to hope, to dream of a future that hasn't happened yet. Your memories, then, every one of them, the treasured and the mundane, the vivid and the vague, were never meant to be a perfect archive. They were built to be alive, responsive, gently unfinished, still being written, in some small way, every single time you return to them. There is nothing to fear in that. If anything, let it feel like a quiet kind of grace, the knowledge that your mind has never demanded perfection from you, and never will. It simply asks that you keep living, keep experiencing, keep gathering moments worth remembering, however imperfectly they may settle, over time, into the long, unfinished story of who you are. Let your thoughts rest now, unhurried, drifting somewhere soft and unfocused, the way memory itself so often drifts, not toward one fixed, final point, but gently, continuously, forward. Thank you for spending this long night here, listening, resting, drifting, alongside the quiet, remarkable architecture of your own remembering mind. Sleep well.